Okay. So here's a program for computing elements of Pascal's triangle, which is this thing that you saw in high school math. And so on, where each element is equal to the sum of the two elements that come before it. In this program, rows are numbered starting from 0, and the elements, the columns within a row, are numbered starting from 0. So this circled element is row 5, column 0, 1, 2, 3. So if I say Pascal 5, 3, I should get 10. The reason I'm showing you this is just to remind you, I hope it's a reminder, that recursion is not always a sequential, okay, now go on to the next word kind of thing, the way it was in the argue case. Here's a recursive procedure that makes 2 recursive calls every time you call it. So it's not like you get to the end and then you're done. It's a much more complicated process than that. This also, by the way, is a very inefficient way to compute elements of Pascal's triangle. Yes? Okay, so sure, walk through it. All right, so if you look at the triangle, in each row, column equals 0 and column number equals row number are the ends of the row, and those numbers are always 1. And that's what the first 2 con clauses are about. And the else clause, the way we compute everything else, says take 2 numbers from the previous row and add them up. And it's a little tricky going from this picture to the code, because this picture, like typical pictures of Pascal's triangle, is written in a kind of symmetrical way. But if you think about it this way, where all the column zeros are lined up, and so on, then you can see that this 10 is the column before it and its own column in the previous row. Is that okay?